Hello everyone, this is Hoda Ganji and this is the 12th video of the parametric design series in Dynamo Revit. In the last video, we talked about creating a curved surface such as this one. Earlier in the videos, we also talked about creating a vertical surface. As we see in this example, all the objects are projected on one single plane. But in the last video, you see that not all of them are exactly on the plane, but a little bit closer or away from the plane. Now we're going to see how we can create some objects such as this one on a set of grids which are not exactly aligned on the surface. So let's go back to Dynamo. I just want to use the set of grids, not the nerves, so I'm going to delete the nerves. Basically, we created a set of grids. Then we created an attractor, and based on the distance of the attractor and the grid, the dots are moved from the XZ plane in the Y direction. Now, it seems a little bit too much curved, so what I'm gonna do is that I want to divide this amount by some number so it's a little bit flattened. So I'm gonna use division. I want to divide this set of numbers by a number larger than 1. And I want to assign the outcome to the amount of translation. Now let's see. Okay, now it's better. And you remember I have turned the preview of the basic grid off, and it was like this before. We had a vertical surface and then we moved the points in the Y direction. That plane is a XZ plane. Okay, I'm gonna turn the preview of the basic grid off. I'm gonna move this to that corner. Now what I'm interested to do is to create some objects on these points and then create kind of a sculptured wall in here. So how about I start by creating some circles, and we can go either with circles or some polygons. You can go to geometry, bring some curves, or you can just use the type option here. I want to create some circles and I want them to be on the XZ plane, so I want to assign the normal as well. So I'll go with the option which requires the center points, the radius, and the normal. So I'm gonna select this option. I'm gonna use the translated set of points as the center points of the circle. You see there are some circles over there now, but first, they are too big, and second, they are actually horizontal. They are not aligned with the XZ plane. We can take care of the radius by assigning some number. I'll go with maybe 0.1. I'll assign that to the radius, or maybe 0.2. So if this is a XZ plane, the normal of this surface, which means the axis perpendicular to that, would be the y-axis, right? And that's what this node asks us here. What's the normal? What's the axis perpendicular to the surface? So I want to type y. As soon as you put y, there's an option for y-axis. That's the normal. And I want to assign this vector axis to the normal. You can also go back and change the step size here. As you remember, we had the points separated from each other by 0.5. I can go with maybe 0.75 or something. So they're a little bit away from each other. Okay. And in that case, I can make the radius of the circles a little bit larger in here. Okay. or maybe 2.5. Now let's see what happens if I extrude these curves. What kind of wall does it give me? So now we have a set of circles in here. You remember we can type extrude and we can have them capped as solids or not capped as just surfaces. I'll go with the capped one, extrude as solid. So the circles are the curves. The default value for the distance is 1. That means they are being extruded by 1 meter. I want to go with a smaller value. You can use either a code block by double clicking, or you can use a number slider. How about we go with like 0.1 or 0.2. I want to connect it to the distance. Now it's getting more interesting. I want to have a set of squares here actually rather than a set of circles. So how about I go to the polygon option. I want the polygon inscribed in a circle because I already have circles. So I want to assign the circles to the circles. And I need to remove this link in here. By just clicking somewhere, you can remove it. Now you see we have some polygons inside the circles. I want to have some squares, so the number of sides should be 4. I can double click, put 4. Now you see we have some squares. You can also go and hide the circles. We don't want them anymore, right? Now it's getting more interesting. What I would like to see is some squares which are rotated by 45 degrees, so they're actually vertical. So I'm gonna go to rotate, and I want to rotate not a vector but an object. This seems good. So it's gonna rotate an object around an origin and an axis. Okay. The objects that I want to rotate are the polygons. So the polygon goes to geometry. The origin is actually the center point of the squares, which is the grid that we had before. So I go to this grid section. So this is the grid. I'm gonna go with this option and attach it to the origin here. Okay, and I want them to rotate by 45 degrees. So I'll put 45 in here and connect 45 to degrees. Also, I want them to be rotated in the same direction of the normal surface. So I want to connect this normal that we had to the axis in here. Now I can just hide the original squares, and this is what I get. A set of rectangles on a vertical surface, and they are moved a little bit away each time in the y direction. How about we make them a little bit bigger? I can go to here. The size of the squares come from the radius of the circles that we use to create the squares. So I want to go with like 0.4 maybe. That's better. You can also use a number slider. Now how about I extrude the new squares that we have? I can connect the geometry to the curve. They're extruded by 0.2. I can go with a number slider here. This could be maybe between 0 and 1. I want to get rid of the code block here and connect the number slider. Notice that it's on automatic. I can put this on manual. I can change the number in here and run it again. You can also put a number slider for that radius of the circles that we had before. I'm going to bring one more number slider. 0 to 1 should be good. And I want to get rid of this code block, connect the number slider instead to the radius. Let's see if I can turn this back to automatic. And if I move this, the size of the squares change. This seems like an interesting wall. There are some gaps between the squares. Maybe if I increase this number a little bit, the gap would just go away. So I'm going to try the best number here, maybe 0.5. Yeah, this now seems better. The amount of extrusion is now the same for all the rectangles, and it all seems good. But if we want to make it more complicated and have different numbers for the amount of extrusion, you remember we used the distance between the attractor and each point to assign it to how further they are from the XZ plane in the Y direction. We can use the same number here to assign it to the amount of extrusion. We might need to divide it by some number, but let's see how it looks like if I directly connect that distance to the amount of extrusion. Okay, so you see some of them are extruded by larger numbers, some of them by less, and now it's a little bit exaggerated, so I need to divide that number by some number to be smaller and then connect it to the distance. I want to use another division here. And I want to divide this number by some number larger than 1. I'm going to bring a number slider for that. Maybe the minimum could be 1, right? Because if I go with a number smaller than 1, it just makes the extrusion bigger. The maximum could be like 20. Okay, I'm gonna put it on like 10 or something, and now I'm gonna use this as the amount of extrusion. You see now the thickness of each element is different, and that gives us an interesting view. Okay, so that's about it. You can import the geometries back into Revit, assign material, and consider this as part of your facade design or your interior design or surface design. Notice that because we have everything based on some parameters, any parameter that we change within the process is going to affect the final shape. For instance, I assigned 41 values to the size of the grid on the Z direction. If I reduce that to like 30, it's going to make the wall shorter. Or you can change the location of the attractor, right? If I move this somewhere else, it's gonna affect the whole shape of the wall. I'm gonna use import geometries, this one. Import a collection of geometry into Revit. And let me put this on manual, it might crash otherwise. I'm gonna save this, Ctrl S, and connect the solids to geometries and manually run it. Now if I go to Revit, see we have the objects here. I want to save this file and close it. I don't need Dynamo anymore. I just need Revit now. It all seems good. You can go to object style, imported objects, and here if you click on this plus sign, the second item here, that's where it's reading the material from. So you can open all of them and select the whole rows in here. Go to the material and assign some material in here. Or another thing you can do is not to assign the material in here, but to assign the material in the software that you're using for rendering. For instance, if I use Twinmotion 2020 and I go to C in Twinmotion, it would be much easier to assign the material in Twinmotion itself in this case. It's a new project. You see all the boxes are here. I can go to the library and materials, and you can select any material which seems interesting. I can try maybe plastic. Or you can go with the wood options based on how you're designing the wall. Next we can create a camera view, and this is actually part of your design. So in your Revit file you have some walls, you have a good space and everything, so it's not only one single element, right? I can go to export item in here and select image 2, start export. So in this case, you see each of the columns are being considered as one geometry in Revit. Okay, now I want to delete these objects in Revit and bring the Dynamo back and see how else we can import the geometries. So I had used import.ByGeometries. Maybe I could use import.ByGeometry this time to show you how different they are. Here it says import a collection of geometry into Revit as an import stance. I want to delete this one, connect this one, and run it. Okay, let's see that in Revit. Let me save Dynamo and close it. Now this time you see each of these elements is now one single object. Okay, so when you import them as geometries, Revit tends to group them, but when you import them as geometry, they come one by one here. In this case, if you want to assign materials, if you go to object styles, go to import objects, there are too many objects in here because each of them is one single object. That's why I used import by geometries before. However, in this case, if you want to manipulate the geometry in Revit, you can do that. Let's say you want to consider some space in here, so you can delete a couple of these items in here. Okay, and now you have one open space in here. Let me delete some of the items in here as well. Let's say there is a shelf or something in here. Okay. Now you see some objects there which are not actually there. As I mentioned before, they are just ghosts from previous geometries in Dynamo. So I need to save my Revit file and open it again. It's gonna be my maybe week 5. Okay, save it. If I open Revit file and open it again, the ghosts of the geometries go away and only the final product would be there, right? So now again, you can have control on each item one by one because you imported them differently back into Revit. Now let me bring Dynamo and show you one more option in here. How about I delete the whole thing in here? Okay, I'm gonna open the Dynamo file. This time I want to flatten the list that we had and then import the objects. Okay, so let me run it. So you see we have a list here with 600 objects in it, and it's made of lists within lists, right? So if I scroll down, it's actually 20 lists, and in each of the lists we have 30 items. That's 20 by 30. How about I flatten the list first? Okay, so type flatten, I can flatten the list, and let's see what happens. So if I flatten this list, I still have 600 elements, but now they're all in one single list rather than in a set of lists inside a list, right? So I'm going to use import by geometries again and see, now that I have flattened the list and it's not a list within a list but only one single list for all the 600 objects, how it's different in Revit. Now that we have flattened the list, I'm going to connect this to import by geometries. This is a manual, so I need to run it. Now that it's flattened, all the elements are considered as only one item inside Revit. So if I go to manage and I go to object styles and I go to imported objects, it's actually one single item. The good thing about it is that it's much easier to assign material or anything because it's only one. The bad thing about it is that you cannot manipulate the objects in Revit anymore because they're all one single element. Okay, so depending on what you plan to do next in Revit and what's your preference for assigning materials, you can go with either single objects using import by geometry. You can go with a set of objects using by import by geometries, or you can flatten the list and then use import by geometries. Now let's try one last thing. I want to delete this object in Revit, and this time I want to use import by geometry using the flattened list. So I'm going to connect this to this item. You see, it's again a combination of individual elements in here. It's not one single element anymore. And that's the difference between by geometry and by geometries. Even now that I have used the flattened list, when I use import by geometry, it will bring them one by one into Revit.